welcome to another weekly live stream. This week we're going to be trying to follow the paths that we created in the previous live stream. I've tweaked them just a little bit, but mostly it's what we did before. So without further ado, let's go ahead and get into it. Scrolling there on the left, you can see the, here, let me move this down so that it's not in the way, so to speak. You can see the patrons. They're what helped me keep the lights on here. I really appreciate those of you who've stuck around through thick and thin. It does mean a lot to me, so thanks. I'm going to minimize this. In the upper left, you can see the download link where you can download the last version. I meant to cut a version last weekend, but I ended up working day job work. And while I did work on Mythruna, I was in no position to cut a release on Monday because I worked a long day on Monday as well. But there's some cool stuff coming, UI fixes and things. And then I went ahead and added some new block types too. In fact, let's go ahead and show you. I'm pretty sure I'm going to let all of this go in. It's, again, perfect is the enemy of good, right? So the big deal first is that there's like that warning screen. It'll only pop up once per release, and you can pop it up again if you want. And then it has changed, so you can read the new one when the release comes out. And then you can also hit this What's New page, which will pop up automatically for a new release, but it'll tell you what the current version. You can go back through however many older versions that I've left in to see. So this is what's coming in the next version. Some of that I think I showed you guys last week, so yeah. So let's get into some new block types. Yeah, so these, I'll show you these. I need to change how it randomizes these though, because sometimes you'll see repeats in here because it is truly random, and so it'll pick the same image. Not necessarily in a row, but it could. But you get like one image back right after another. So I think I need to shuffle that and then just index through them. Well, according to YouTube, we don't have anybody on tonight, but I'm going to keep going. All right. Because I know there's quite a few people who watch this after I stream. The other thing is I'm working on a chest cold, so there is some likelihood that I might end early depending on how I feel. Okay, so I was in here because... Oh, hey. Hey, Ron, how's it going? So I was in here because I was looking at how the stairs were constructed, because the physics playground, I've added stairs. So one of the things I changed, I added this new frame block type so that when the houses are being constructed, this, again, this is kind of a tentative block type. I think I'm going to go ahead and release it, but it creates its own set of problems for me. For one thing, it is solid as far as the physics are concerned. So if I threw like a teeny object at it, it wouldn't go through the slats, because as far as the physics is concerned, it's solid. And so that could become a problem later. We just need to know that. I think I might try to slip another set of slats in the middle, just to make it look a little more solid. And of course, the big cube, it looks like I should be able to fire an arrow through here, right? But I can't. Other thing, I was trying to make, like I thought, so the other thing I added, and I'm going to go ahead and go back downstairs. I don't want to take out blocks. So that's the first thing I started to add was these wattle blocks. So it's like the wattle without the daub, right? So that first you would have these frames, right? And then the NPCs might bring a bunch of sticks over and fill them in to make the wattle, and then they would come back and apply the daub, and then you get the wattle and daub, so that they could construct these houses like in frames and so on and so forth, which I thought would be cool. I was going to say something back there. Anyway, these are the new block types I added. And then, the windows. So, whoa, hello. Sometimes my monitor cuts out. You guys didn't see it, but I did. So if we go to the glass, now we've got like leaded panels, which are these kind of windows. There, oh, I did it wrong. Okay, so these kind of windows, you can see there's like glass in those. So yeah, you've got cool new window type you can use. And then the other thing is there are wooded panels. So this is a sort of a typical sort of glazed window kind of window panes. And then the other one is for desert environments. I thought it would be cool to have, I've got all the sample windows over here. Oh, it looks like we picked up the second viewer. Good. So I've got these sort of breeze panels where you want to have something block your window, but you want to let the breeze through. And the thing I like about these is they can be used as railings too. So I've created this like little gazebo over here with railing. And again, this creates another physics problem for me too, because this is a solid block. That is not, you cannot shoot an arrow through that panel. And maybe someday I'll make that work. The other thing is they're thin enough that they mess with the physics. So that's something I'm going to have to deal with as well. In fact, that's the first time that's happened. I mean, I've been able to walk through them before, but I've never had them glitch out like that. That was weird. So yeah, I just walked through it. Which means that even the glass panels would do that. So that's a physics problem. That's something I'm going to have to fix eventually. But the fact that we already have regular glass panels that should end up doing that, and of course if they're, yeah, see, I just walked through that one too. Yeah, so let me see. If I had the regular inset panel, boink, boink. So that means I should, yep, I can walk through those too. Yeah, so there's a physics, that's a standard kind of, even regular video games have that problem physics, which is why walls tend to be really thick, like overly thick in video games. My cord is tangled around my ankle there. There we go. So that's something I'll have to fix. There are ways to deal with that. All right, so that's, I think, the features that I added, which are just new block types, which I think are pretty cool. I feel like there was some bit of thing I got working that wasn't working before that made some of these possible, but I don't remember what it was. And so there's still bugs. The specular for this, you can see how the window, whatever they call them, the word escapes me now. They've got, the wood parts here are shiny, and that's not supposed to happen. And I've got a specular map here that says that's not supposed to happen, but it is anyway. So there's some bug in the shader that I'll have to fix at some point. But anyway, it's pretty cool looking, and I've been making sure that whatever they are, that they still look good in the hand-drawn, so that, yeah, look at those windows up there. You can really see it really looks like glass, and so to do this, yeah, you can still see kind of the shape and stuff. So anyway, that's that. Let's get back to what we're going to work on today. While there's still Pepsi and it's still cold. Yes, so I messed with this today to make the debug shapes a little more efficient. The debug text that appears is still not, but and then I tweaked some other things to make the visualization a little clearer. And I added this tower with the standard Mythruna stairs to make sure, the stair pattern that I use for double stairs, to make sure that the character could walk up those stairs. So let's put a character down up here, which is what we were playing with last week. And let's have him go, or her go, down here. So she should walk down the stairs and so on. So I've cleaned up the debug a bit so that when this pink shows which candidate, so when we start, there's only the one candidate where she's standing, and then where we can branch out from there. So remember, we start with a position, and then we iterate out to see where the next places we could go, and we add all those to the candidate list, and then when I hit step again, it'll pick one of these, the best one so far, based on cost and the heuristic. But it's got some debug indicators here telling me what's going on. So here it's showing that the other thing I did is I made that these are semi-transparent. If you're looking through blocks, you can still see them. So when we have red stuff inside and so on, that still works. So what we have here, I'm trying to get like a good view, these all mean different things. So this is a contact that is below our feet, but not so far below our feet that we would fall. Whereas this is a contact that's below our feet and below far enough. No, that one's even considered. Yeah, I can't remember what pink means actually. Pink and yellow, I can look. We could do that, and then I wouldn't have to guess, right? So let's look for pink. So pink, yeah, that's not it. So pink is, okay, so yeah. Pink is that we've got something that would, if it was facing the other way anyway, it would block us, potentially, it is within the range of something that would block us, but it's, within the range of something that we could step up or step down over. Right, so we did get a contact there, and it's facing away from us, which I would like to have eliminated all the things facing away from us, but there's a reason with the resolution of the physics engine that I have to pretend like those are facing towards us, because if this was a really thin wall, I might not get the contact facing us. I would only get the one away, and I should still consider it a block, because something is definitely there. However, this is within the knee to below, where I can just consider it a step. I can step up or step down. And the yellow means, where's the yellow? Yellow means I'm stepping up. That can't be right. The rel vector is less than, okay, so there's a missing if statement in here, because that something else should have picked up that this is below 0. It doesn't really matter because I can step down. This isn't really affecting me. Anyway, these red ones mean that I looked and I didn't find any place to stand, which means if we tried to go there, we would fall. The green arrows mean I can stand there. And so when we hit step, it's going to pick the best of these, which we can look and find which one. We can kind of eyeball which one's best. So this one cost 1, and the heuristic is 11.75. This one cost 1, and the heuristic is 13.04. So this one is the next best one. And so if I hit step, it's going to move that pink marker here and branch out again. And so this will be the next best one, and so on. And then it'll keep trying until it reaches a point where it has to go back and try some other ones because they're lower cost versus their heuristic, and so on and so forth. And so we can see now which part of the search tree it's searching. I'll go back and I'll fix these other collision issues later. That's basically where I'm going to spend all of my time with mobs, is tweaking the collision algorithm to figure out which paths they can take and which not. And what we're going to start working on today, which is the physics to control them to follow that path. There will be 1,000 edge cases that need to be covered. Because already there are ways that you can confuse the current query stuff to block a path that's not really blocked. We talked about that before. If you put an object in the wrong place, the mob will think they can't go that way. So anyway, it'll eventually figure out that it can go down the stairs. It's already sort of heading that way, right? So it's trying to get here. And so it's taking all the paths, and eventually it gets someplace where the cost to get here is lower than all the other costs, and so it tries that. So it like explores all of the paths to get there. Because it doesn't know. Maybe there's another step down here that it doesn't know. I have thought of, so the other thing we talked about before is tweaking the heuristic. It's about to finish. Yep, so it found the path, walks this way, goes down the steps, and comes around here, which is pretty much the ideal path. We talked about tweaking the heuristic too. Currently I'm just using the pure distance-based heuristic and not the distance squared version, because the distance squared version makes strange paths super aggressive. But I think, again, that's number 3 on the things that I'll spend the rest of my life tweaking, is the heuristic to make them look smarter. And I had this idea, I'm not going to implement it today, but given where you are, like, so if I'm trying this candidate here, I ought to be able to cast a ray through the physics engine towards where I want to go. And, normally I would just take the straight distance as the heuristic, but I could see if it intersected things along the way, and if I hit, 1, 2, 3 walls, I could increase the heuristic cost so that it looks like more. Because that's what we're trying to do. We're trying to estimate from this particular position, what do I think the cost will be to get there. And so if we start to include sort of the obstacles in the way, that might be enough to tweak the algorithm to try better paths first. And certainly from a mob standing here perspective, especially if I don't know the area, I'm more likely to take the paths I can see anyway. So that's a potential tweak to the heuristic. Anyway, we can see also that if I delete her and put her down here, and then set like her to go up the stairs here, and then step. In fact, let's move over so we can see. I can't remember my controls. So move over so we can see a little better. So she will work through she pretty much should only go forward mostly. She'll come back and check those, because again, the costs of these are really low, and so as the cost gets higher because she's walked in that direction, sometimes she'll go back and check these lower cost ones depending on what the heuristic says. So she's starting to go up the stairs. Going up the stairs is a little more expensive, so she ends up trying other paths. See, we can see through the wall, so that's kind of cool. And so eventually she'll make her way up the stairs and up. She's going to get there soon. Yeah, see, these are all the best ones. And she made it. And so she's got this walk path up the stairs. We can't see really the green one. Yeah, so you can see the green ones. So one of the next things I'm going to do is, when she figures out her full path there, I'm going to wipe out all the debug stuff and just draw the green path with the little lines between it. I think that will that'll be cool. And then we can also eventually, when we just want to be testing her walking along that path, we can up the iteration count so that step would run. Like if we check, it took 83 iterations to find that particular path. And so we could up that to 40 or 50 so that one step would take us burp, burp. Or we could make it 500 or something, so it would always, or mostly tend to find it within one thing, and then we can add a little walk button to have her walk the current path. That's what we're going to try to get done tonight. But anyway, I'm pretty pleased with how it's turning out so far. I when I first started playing with it this afternoon, I was a little disappointed, but then I found some easy bugs to fix in the detection, and I made some other tweaks. Like, I think last week we made the collision box that it's using to query, we made it slightly larger so that it would detect these walls better. But when I did that, it created a case where she couldn't walk through these kinds of places anymore because her collision box was too wide. And so instead I shrunk it back down to be the pure, 0.5 or whatever, the half of or a quarter of a block. Yeah, 0.5. And then whatever direction we're querying, I pull it back a little bit, which also I think prevents us from walking through, like, I think we found out she walks through like corners like this where it's like there's really, she would be sitting at this corner and she figured out she could walk through there, even though in reality she can't. I think it fixes those cases. In fact, we could check it. So let's remove her, create a mob right here, and then we'll say go to just on the other side, and we'll see if she makes it through the wall. Let's move over so we can see a little better. Hold on, I want to get zoomed in on her. I need to make a center button that would just make us centered around her. Okay, so it's already figured out it can't go here. So step one more time. Okay, it's going to try here, and it figured out it can't go in any of these directions. Yeah, so it's working. So she's not going to walk through here. She shouldn't. Yeah, because it put red here, so it knows she can't go through there. So it should go around the corner. Yeah, I think this is the exact case where last time she walked through the corner. And so now she figures out how to walk around. So anyway, good stuff, and I'm pretty happy with that. But that is where, in these kinds of things, when eventually you guys are reporting bugs that mob pathfinding is being stupid and stuff like that, that's the kind of stuff I'll end up tweaking, is figuring out. I'll load it back up in here, try to create the situation, and figure out how she's cheating the physics engine, or how it's getting confused, and so on and so forth. All right, so I started breaking things up into different Groovy files. So we used to have the setup driver, which just had all of this stuff in it. I moved the pathfinding portion over to here. And so from here, we ought to be able to detect completion down here in the find path where we detect that we've finished, right? We're already where we're supposed to go. And so we can, in fact, let's make it, so basically in here we want to create the path to walk. Right, and so I think we'll just continue to use the structure we have, except for it's backwards. Okay, so I wanted to have the debug view set up so that I could talk a little bit about it. So before we actually get to following the path, let's get it set up like I talked about so that it'll show us the final path and clear out all the other stuff. Excuse me. Yeah, so where do we draw? This is where we've already figured out we're done. Right? Where do we draw all the green boxes? Do we clear the queue? Oh, we draw the path right here. Yeah, so create path. And so where we find draw path, let's make a create path. Takes the same stuff just because I didn't know what better to take, really. And so then for the state, we'll set up how do I want to define this? List current path. For now, that is what I shall do. And so then, instead of, yeah, so this is calling recursion and drawing the thing. And instead, in fact, I'm going to replace that. So instead, we'll do a while loop here, or a for loop. Current equals candidate. Current not equal to null. Current equals current dot parent. Yeah. So right, if you guys don't know how essentially the candidates become a linked list. So you've got let's see, am I already logged in? Yeah, okay, I am. So you've got where we started, and then when we make another candidate path, it points back to this one, and then the next one points back to this one. And so when we get to the end and we go, yay, this is the one we want to go to, we have to work backwards. So we go to the parent, to the parent, to the parent, and then eventually we get where we started, right, where we were standing when we started. So we have to go backwards. That's what the parent is, parent, parent, parent. We originally branched out to all these different ones, but when we finally found the one, we iterate over it backwards, which is what this code is doing. What code? Where'd it go? Yeah, this code. So it's saying, we'll start at our candidate, and as long as that candidate's not null, the next pass through loop will go to the parent. And so we'll be starting with the current one, and then we'll go to this one, then this one, this one. And so because we're going through them backwards, but we would like our path to go forwards, we are going to add things to the beginning of the list. And so we'll do list add 0 current dot location. And excuse me, and we actually want the real world version of that. And that should be okay. And then we will set that to the state current path equals list. I think I didn't just create bugs. We're not, we did. I created a bug. Create path is applicable for arguments. Create path. 1, 2, 3. 1, 2, 3. Ooh, that's loud. Path actions, create path. Oh, I forgot the equal sign. Yeah, it's a groovyism. It trips me up a lot. Okay. And so I think instead of draw path, we're going to make a different draw path. This one, draw path 2, I'll call it draw path 2 equals, haha, and we'll just make it list path, draw path 2 current list. And so in this one, we'll just make a bunch of arrows, I think. And where do I clear the path entities? Path entities, path entities, path entities. Where do I clear them? Here we go. Clean path. So create path. For here, we'll do clean path. What were the arguments again? Dope. Agent and state. Okay. Driver. State. We'll stop doing this one. And actually, I'll do it here. State current path. Oops. Rather than in here. Alright, so we want to do something similar to this, except for we're going to draw arrows. So for the path, I could have also done path each, I guess. Oh, in fact, we're not going to be able to do this. We want to do because I want to be able to link the previous one to the next one. So we'll do I equals 1, I is less than path.size, I plus plus. So we'll skip 0, and so that way we can do something like this: path.get I minus 1. Okay, so we want to draw an arrow between that one and that one. And so we will say shape equals debug shape, create arrow, and arrow takes a layer, a tip, and a color. A layer, which you don't care about because I didn't implement that. B2 subtract V1 and a color. Color RGB a dot green. Let's use yellow. All right. And then entity equals we're gonna want to get that. Create entity, ed set components, shape, and we need a position. So let me steal somebody else's body position code. Body. Okay. So we want B1. And we're going to add a little bit to this so that it sits up above it. Okay, and so bpos comma shape. Okay. Let us see how badly I screwed up. So we'll clean our path, we'll go to here, and then we'll step until it finds it. Uh-oh. Okay. Bad things happened. Set components. Oh, I didn't pass the entity, and I also didn't add it to my path entities so it wouldn't get cleaned up if I hit the clear. Okay. Let's try again. So, clean path, go to here. Step, 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 step. Yay, look at that. Okay, so that's the path she wants to take. Arrow, 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 arrow. And this is what I wanted to talk about. Let me center it over her. So, for pathfinding, you don't really want to walk from this point to 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 this point. You kind of want to have her go in the direction of the path as close to the path as she can get. And the reason is that that covers cases where something might be temporarily in the way and she can walk around it. Because I don't know if you remember, but our mobs, the way they're set up from a top-down point of view, you know, if you imagine the Gafen has a beak, right? You know, he's heading this way, and he's got this probe sphere in front of him that if it gets close to a wall or something, he'll turn in the other direction to kind of, you know, self-navigate around small obstacles and stuff. And so consequently, you know, if you've got this, you know, case where you're moving from here to here to here to here to here, you want them to sort of go in these directions and stay as close to this, kind of like a rubber band, as possible. But you don't necessarily need them to get to this point, then arrive exactly at this point, then arrive exactly at this point. And that way, if like somebody drops something here, the mob will walk around and still keep going. Or if there's, you know, a player standing here, you know, it'll kind of avoid colliding with the player and just keep walking and kind of get where they're going. And depending on how you define, you know, how close am I to this path and which direction, you can make it auto smooth around these corners too, which would be a nice effect in the end. But that all being said, I think I'd be pretty happy if today we can see her walk, or not walk, because she's not going to animate today, but move down this path. So that means we've hooked up the ability to do that. But so far, so good, right? We've got a little thing. We're trying to get there. Okay. So now we ought to be able to add a walk. We're going to int next node. What do I want to call that? Next waypoint. We'll call them waypoints. It's not exactly accurate. But I just want to see if we can control her with direct velocities. We'll probably want to clear the path. Okay. I guess we can leave this over in path actions. Well, no, because we're going to want her to queue up motion. Okay, so I'm going to... Alright. So let's set a new... something called walk. And so that should make us, yep, we have this little thing. It doesn't do anything yet, but we've got the thing with the stuff. And let me create a you plan like you have done all of these things before. I plan like I've done all these things before. I've thought about it a lot. I've played with the idea before, and yeah, in some cases I have. Like there's an old video I have, you search back through my archive, but it actually has a top-down view of mobs that are trying to get from one place to another, and I have like a whole mess of them, and they're just represented by spheres, I think. And so they have this kind of spring tie to the path that they want to walk. And so as a crowd, they all go through, and even if even when there's a doorway that they have to get through, and there's all these mobs, because they're all trying to get from here to here, they will squeeze through. Like one will find his way through, and the other one will squeeze in behind, and they eventually get in and they spread out again, because they're all sort of spring-loaded to the path. They're all trying to walk that same path, and they figure it out amongst themselves, kind of mass and forces and things. But so I have played with the idea before, yeah. So I've hit these pitfalls before, and I'm trying to avoid them on this go around. I'll find a whole bunch of new pitfalls, which is what always happens. All right, so if we have we say walk, we want to hook something into the state that says, actually we can, since we're not going to be doing the follow the path thing yet, what I can set up is just that next waypoint is just a way to walk there. Come on. Actually, next index. Okay, so that's going to do that. And then in here, there is no... I think this is still being used. Yeah. Okay, this is still being used. It's just not doing anything. But why isn't she turning around? First of all, let's create her out here somewhere. So like she turns for a second because there's no dampening at all, and I'm trying to figure out why. So we set the states, y'all, but we don't do anything with it. That's why I have all this commented out, I guess. So we calculate the desired thing. We don't add any forces. And I think what I'm going to do for now is just set the velocity to be whatever the next waypoint is, towards the next waypoint. So let's say if there is a next waypoint, if state next waypoint, calculate what it takes to get there. So state next waypoint relative equals, or just to call it dir, this subtract our current position. Actually, let's save myself a bunch of time. Rigid body equals driver dot body. And then I can do this. So we subtract body position. We normalize that. And so, like, even if you guys have any questions about what I'm doing, I can also dive in deeper about what I found out, how I learned that particular lesson if necessary. But a lot of it's just having thought about this for 15, 20 years. Blah 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 blah. So we normalize the direction. And then I think for now we can just set linear velocity to that dir. But we also want to check the length. Length squared. If distance is less than, let's say, 0.01, then we'll go to the next waypoint. So we'll set we'll make them pause for a second. Actually, I can just do like this. So we'll kill all forward velocity. Again, this isn't navigating through forces, so this is more like jetpack, no gravity kind of movement around, like almost a kinematic object. So if the distance is less than 0, then we want to check our next waypoint, which if next index is less than current path dot size -1, then state dot next waypoint. Oh, this is interesting. Yeah, so I get something for free here if I start at 0. Yeah. Next index ++. Okay, so this will set if we get within 10 centimeters of our target. Well, 0.1 square root of what is the square root of 0.1? Yeah, so 0.33. So if we get within 30 centimeters of something, in fact, maybe I want to make this 0.01. So that would be 0.1 times 0.1. So it's because this is length squared, right? So we have to, anyway, yeah. So if this means 10 centimeters, even though it's 0.01, because 10 centimeters times 10 centimeters is, anyway, whatever. So if we get close enough to our target waypoint, we will hit the next waypoint if there is one. Otherwise, we'll just kill velocity and we'll be done. And else, yeah, so else we'll set the next waypoint to null. And so by doing this, I think to bootstrap, I just have to say down here to walk, I just have to say, how do I grab the state? Like this. Okay, so to start walking, I should only have to, so if we've already got a waypoint, we'll say already walking, in case I click it twice by accident. Okay, so if we don't have a waypoint, we'll set the state next waypoint, or if there is no current path, or state.current path is empty. Nope, that's a different condition. It would have been fine except for my log statement wouldn't make any sense. So there's no path to walk. No path to walk. So next waypoint. So otherwise, we'll set the next waypoint to be the state.current path 0. And so we should already be there. And if we're already there, oops, next waypoint. And so if we're already there, we have a next waypoint. We'll calculate our direction there, which will be 0 or close to 0. And yeah, so we'll detect that we're close there, and if there is anything in our path, or if there is another waypoint in our path, we'll set that as the next one. No, we won't. Not unless I do this. Alright. Yep, so then I don't have to do any of this stuff. I can just set that. Oh, you probably want to set state next index equal to 0. Okay, so in theory, she should move through the waypoint. So let's make sure our paths are clean. We'll make an easy path for her to walk. Step, 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 step. There we go. There's her path. Let's say walk. Uh-oh. She walked to the start because that was behind her. And no such property next index. I didn't reference something correctly. Yeah, there we go. State. Okay. Let's try again. Let's see, can we just hit walk again? Nope, no path to walk. It cleared it. Okay, clean path. Go to here. Step, 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 step. Now she's got a path. Now walk that path. Oops. Yep. No such property current path for class. That's gonna bug me. So again, state.current path. See how many more times I make the mistake tonight. Alrighty, try again. Go to here. Step, 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 step. Alright, we've got a path. Walk. Stop. Cool. And now it should say we're already done if we try to walk again. Oh no. She's going to start the path over again. That's funny. Good after evening, Lando. How are you? Nice. Okay, so that is, we'd have to clear the path when we're done. Or not necessarily clear the path, but reset all of the things. No, I think that's actually what I'm doing. Right. Yeah, so we need to clear the path. Alright. So all the things are cleared. Let's just check. Okay, let's go to, let's make it a little more complicated for her. Step, 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 step. She shouldn't go through the door unless I broke that. Yep, she's not going through the door. Okay, go find your way around the corner. Come on, you can do it. I need to up the iterations for this step thing. There it goes. Yay, okay, now walk. So she's not facing the direction, right? There's all the kinds of things we have to do. She's rolling around the wall. But anyway, she follows the path. Now, will she follow it up the stairs? Let's delete. Actually, we can make her go places now, right? So we can say go to here. Step, 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 step. And then we can say walk there. Yep. Pretty cool. And she rolls around the thing. Yeah. So let's make her face in the right direction, because I think there's some interesting things we can learn there. So if the direction is if we have a waypoint and we have a direction, regardless, let's face in the direction, right? So we will say facing dir, which is going to be dir, but we're going to zero out the y because we don't want her like leaning back and leaning forward as she walks up the stairs. And then I think my quaternions also have a look at. Where is my stuff? Where's my stuff? Okay. Quality. So it does have a look. Ooh, no, it does not. I need a look at. I'm gonna have to steal JMonkey engines. Okay. So have I? Yep, I got JME math. So let's do quaternion facing equals new quaternion. That, and let's look at the JMonkey engine documentation. Look, I think it's just look at dir. Look at dir and up. Yep, okay. Look at facing dir dot to vector 3f dot vector 3f unit y. Okay, and then we'll have to body orientation set new quat d facing. Let's see what I screwed up. Okay, so let's make her go to here. Go to clear green black. Go to here. Uh-oh. What is this? Path actions. Okay. Clean path. Go to here. There we go. Step. Find your way there, lady. There we go. Let's try to walk it. Yay. Look, she's facing the... see, this is what I'm talking about. The springiness. She got stuck on the corner there. If she had proper probes and some... and was only using the path as a guide, it would have worked out much better for her. Okay, so then... Clean the path. Go to here. Step. Walk. So she faces down the path when she walks it. That's sort of one of the primitives we're going to need to do the elastic version. Step. She should head straight here. Boink. And then we walk. Then we'll have her try to go up the stairs. I just wanted to make sure the verticality works. Okay, so clean path, go to here. Step. This is going to take her a little bit longer to find out. In fact, let's clean the path and update the iterations. Path actions. Iteration count, let's make it 10. And where do I control whether I draw the current? Draw current, show current steps, false. That's what draws the little pink guy. Okay, so let's go to here. And then step. You know, if I had left this on, I actually did make it so that it would show us every path it tried. So that, that's where the little pink marker shows us which node we're trying, and it's supposed to show us every one it tried to get there. And so then it'll replace those and replace those. And so it's showing us, you know, how it's searching the paths. I just thought it might be distracting, but maybe it's cool. I don't know. And so she's making her way up the stairs. And eventually she'll get there. And boink, that's the path she needs to walk. Hey, pretty cool. Let's see if she can do it. Walk. Up, she's making her way up. Look at that. So with pure velocity, at least, she can make it up, even with gravity involved. So yeah, check it out. Ha ha ha. And she's got no input anymore, so she's just doing whatever the last physics collision told her to do. Ah, pretty cool. And actually, she should be able to step off of here. Oh, I didn't even think about that. So she should be able to just walk over here, straight over. Yeah, check it out. Whee! That's neat. So that means that there is more than one way to get up on these upper walkways. You could take these steps or you could take these steps. And yeah, so which is the faster way, do you think, for her to get down into this room? We can check these things now. So if I say go to here, is it going to be faster for her to head back this way and go down the stairs? Or faster for her to head all the way around here and go down these stairs and then around the wall? And it'll check all those paths now. Rump, 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 rump. Maybe I'll get a little closer so you guys can see better. Doop, 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 doop. It's trying to get down there. I think she'll end up going down this way first because she's still messing around over there. Oh, but no, it's got to go all the way around. Oh, this is going to get slow. I've left too much of the debugging on. Yeah, so see, all of these things here, they're not free. Let me see what else I can turn off. Show cost labels, definitely false. Show current steps is kind of cool. Let's turn off of all the arrows. So let's call this show contacts. And make a boolean up here. Boolean show contacts equals false. And is there anything else? No, I think we'll leave those. Alright, so we're going to have to do the path again. Ooh, see, it's so slow. I should bring up so you can see what I'm experiencing. We're running 3 frames a second. So we want to go try this again. Go to here. And step, 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 step. Oh, yeah, so much faster. See, we're still maintaining about 50 frames a second as we search all these things. And we can kind of still see what's going on. She's making it down the stairs. Ooh, she made it. Look at that. All right, let's see if she can walk the path. I've got, according to YouTube, none of you guys are watching anyway, but I'm still cool with talking about it. Okay, so she'll go up there. She'll walk the whole path. Yeah, so she had elastic would have helped her here. Yeah, I think YouTube is lying to me. So thank you for mentioning it in the chat. This little dashboard thing is just complete garbage, I think. Okay, so cool. She found her way down that way, which is kind of cool. And that means if I make her... it's just hard not to play with this, guys. Right? Like, see what it'll do. Like, what if she wants... Oops, clean path. Go to here. Like, which way... Is it better to go up this way? Let's see. Ah, that looks so cool. Like, it's showing us the front, you know, of what it's trying to go. So she's going to get up these stairs first, I think. And... Doink, doink, doink. Oh, she made it up the other stairs, too. It's going to be a close one. Right? Which is going to win? Oh, I'm actually... okay. Surprise moving ahead over here. Hey! So it was kind of neck and neck. So she'll walk this one. She'll kind of roll around these because they're a little too close to the wall for her shoulders. Uh-oh, yeah, she almost got stuck there. She is stuck here. That's because she's stuck on this little, yeah. If I make her jump for a second. Oh, jump is not working anymore. I must have, because when I decoupled the desired velocity stuff. Oh, because it's constantly setting the velocity. Yep, so she's good and stuck right there. Maybe in a way that I can't fix. Like, can I get her to walk back over here? Step. Okay. Walk. No, she's already walking. Yeah. So, I could add a stop walking. Ooh, there we go. Stop walk. And so if all that's good, all I have to do is set step next index equals 0, state next waypoint equals null. And whether she's walking or not, it'll just clear all the things. And so I should be able to just stop walk, and that would clear whatever she was doing. But yeah, that's unfortunate. Like, that means she can't, even if we find our way up there, she can't go there. Oh, she might make it this time. Hey, she made it this time. And so perhaps with the spring and the, yeah, because with the probe, she would have turned, I think. If we put the probe up high enough to not get caught on steps, she'll step up. Anyway, I'm pretty happy with that. It's like we've got technically an hour of the live stream yet, and I'm pretty happy with this. So now we can look at following the paths. And maybe I can set it up to reset so we can keep using the same path over and over again. So let's do that. Maybe instead of, if we're already walking, maybe we reset ourselves. Can I do that? Let's say already walking, resetting. Okay, so instead of this, we'll set it to be next, wait, yeah, so we'll start over. Oh, we were already going to start over if we didn't exit. So if the current path is empty, we won't do anything. If we've already got a waypoint, we will move ourselves. So I think agent, body, position, set, state next waypoint. Or not next waypoint. Current path 0. Is that going to work? Okay, so let's see. Can I make her go down here? Step, 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 step. We've got a path. Okay, she should be able to walk the path. Because we're going to want to be able to test the same path over and over again once we've found one, right? So she gets there. Can I click the walk button again and have her start over? Boink. No. No path to walk. Something cleared it. we don't want the path to be cleared. Yeah, we don't want this here. It's only important to clear the waypoint. Okay, so now we can clean the path, make a shorter version. Step, okay. Walk around the corner, yeah, because this is going to be a good test anyway. Okay, we're back. Can we walk again? Boink. Oh no, she's trying to walk back there. It did not teleport her. Why didn't it though? What happened when I set this? Walk. Already reset. Oh, so it did start over again. So why didn't it do it this time? Walk. Oh. No, she gets to the end. And how are we detecting that she's already walking? Because she's got a waypoint. So let's put a done here. Right, and so then when she's done walking, we set the waypoint to null and state done equals true. And then down here, when we start walking, we set state done equals to false, and we do that again if we stop the walk. Stop the walk, can't stop the walk. I'm sorry. And so if we already have a waypoint or the state is done, like we got to the end, then we'll walk again. Yeah, I think I can't. Yeah, there's no path. Okay, so clean, go to here, step, step, okay. Walk, she should walk all the way to the end. Whee. And then she's done. We should be able to do this, and boink, she walks it again. Okay, cool. And she got stuck. She made it. Yay! Uh-oh, into the Pepsi. Okay. Yeah, unfortunately, the step to go from here to force-based walking might be a bridge too far. So we need proper steering. So right now we are making her sort of, her velocity directly follows the arrows, right? So 1 meter per second sets her velocity to whatever the next waypoint is until she gets there. And what we would really want her to do is steer left or right towards the next waypoint so that we can bump that steering out based on a probe. So I'm trying to sort of gather my wits. So let's go down here. Let's talk about path walking to do. So we need to probe to detect potential collisions. We need probes to detect potential falls. That can come later. Basic steering. to head in a direction with probe effects. So basically, as we're heading in a particular direction, if we're heading, you know, if we're heading in this direction, but we detect that we're so close to a wall that we're going to hit that wall, you know, we'll steer away. And so trying to steer down the path and trying to steer away from the wall, they'll combine, and we'll end up with sort of a, you know, composite steering solution. And whether there's other obstacles and so on, that'll all come into play. Well, the fact that this is slightly crooked really wigged me out for a second when I went over here. Yeah, it's still, that makes me dizzy for some reason, that this is not quite straight. It's unnerving. Oops, wrong one. So basic steering is just, so then, yeah. So this is a big ask. Yeah, so that's basically steering, which is the need a steering function to produce a turn and what do you want to call it, speed. Then we need to be able to turn that into physics forces. And that's sort of where we started this whole process, right? I'm trying to decide how far we can get pumping, using the steering function to control velocity directly. I think that will work because in, you know, kinematic games, that's exactly what happens. So for steering, we need a heading and speed. So for our body state, this extra stuff we're keeping, actually we put it up here. We've already got a heading. And so then we can do like a speed. And so what is it that I want to do next? Well, we can implement basic steering. So with steering, we want to have, I'm trying to think, we want to turn towards a direction and we want to turn away from objects, and one kind of overrides the other. It's not a mixture of the two. So, but let's see if we can just get to the waypoint through steering. Double steering. I'll call it double acceleration. It's not really. Okay, so let's say if false and state. Okay. So now we'll say if state.next waypoint. So we can turn these on and off, right? So if state next waypoint, what we want to do is take whatever our current direction is, whatever direction she's facing, and figure out whether that waypoint is to the left or to the right of us, if it's behind us. And so which direction is the which direction is the waypoint? And to figure that out, we need to know what direction we're facing. And so that's going to be in an XYZ axis. X is left and right, Y is up towards her head, and Z is the way she's facing. So we want to know left or right, so we're going to want her left vector, which is going to be, well, it's negative X, I think is, but anyway, doesn't matter. I already pulled body. Yeah, so body, orientation, mult, new deck 3D, 100. So that's like, we look down the z-axis, and yes, this is the left vector, right? So positive x is to the left, and so that's the left. I'm going to call that left. Okay. There's also dir, which is the one just directly in front of us, and we're going to want to know that too. And so that's down the z-axis. So these are our sort of raw direction vectors. Now we want to know where, let's start keeping track of this, right? We've got our little dude. We've got a place we want to go. It's facing this way. This is its left vector. So this is z. This is x. And we want now to know where this is relative to us. What is this vector? Because in our universe, we are the center. We are 0, 0. Where is this in relation to us? And so if we find that out, that is going to be the rel of, we'll call it vrel. So that's going to be wherever we want to go, state next waypoint, minus the body position. So this position minus this position is going to give us this vector. And so from that, we can take the length of the whatever that is, right, length squared, and this all still is the same. We would want to say we want to make the so if we're close enough, we still want to set the waypoint to the next path, in which case we're going to have to do this. Oops, we're going to have to reset our vrel, right? Otherwise, we set it to done. We can this is where things get weird, because we're not doing this as a separate function, so we can't just exit out. But right here, we would want to just be done. And that's going to be hard. Well, what we could do is if we could just do this and say if we're already there, don't do anything else. Like if we're already to the current waypoint, don't do anything else except for set the next waypoint. Right? And then otherwise, we'll figure out the best way to go to the current waypoint. Right? And that's where we need to know our directions. But we've already got the relative direction, and so we can say how much do we want to turn left? Turn left equals left dot vrel. So basically that's going to project this this onto this axis, and so it will end up, like in this case, we'd end up getting a negative value down here, because that's the projection along here, and that's what the dot product will give you. If it was to this side, we'd have a positive. So basically, if it's negative, we'll turn right. If it's positive, we'll turn left. But if it's behind us, we need to do different things, and so we'll check what's behind us. So let's say forward equals dir dot dot vrel. And so this is going to tell us how far down this it is. And in this case, it's in front of us, right here. So we'll know what this distance is, and we'll know what this distance is, and we'll be able to use those. If forward is less than 0, that means it's behind us. And then if turn left equals 0, then that means it is absolutely behind us. It's sitting back here somewhere, and we don't know which way is the better way to steer to get there. So we will arbitrarily set the steering to 1. Basically, we'll turn left. Else, we'll set the steering to be whatever value we have. What is it? I can't remember whether Java uses Signum or Sign. S-I-G-N. I think it's Signum. Basically, if it's negative, it'll be -1. If it's positive, it'll be 1. It's Signum. Signum, yeah. So it returns the Signum 0 if the argument is 0, 1 if the argument is greater than 0, -1. So basically, it's maximum steering in whatever direction turn left is, right? So if forward is behind us, that we do some special stuff. Else, we're just going to in fact, yeah, that's fine. Else, we're just going to set steering equal to, well, we want to normalize it. So we will say if steering is less than 0 or less than -1, we want to clamp it, but there's no convenient clamp function in Java. So if it's less than 1, we'll make it, or less than -1, we'll make it -1. If steering equals turn left. And then we could probably clamp this. Now, eventually we're going to need to combine this steering with something else. So if it's greater than 1, steering equals turn left. So I don't want to monkey with its value. Otherwise, steering, yeah, so steering equals 1. So out of this if block here, or these if blocks up here, out of this if block, we should have steering and acceleration set, and steering should say if it's 1, we need to turn left. If it's -1, we should turn right. If acceleration is... Oh, that's a good point. We didn't set acceleration. Acceleration we would want to set based on distance. If it's forward, if the thing is behind us, set our acceleration to be small. Otherwise, set acceleration to be whatever is smaller, the for or the distance. And actually we'll want to do mass square root distance because this is squared. So we should get some, I think I actually got compile errors. Yes. Yes. Else. Oh, that was the only compile error at least. Okay, so then we need to do something with that. And I'm going to get rid of all this stuff for now. And just set, so we want, there's going to be like a turn rate, double turn rate, which is going to be how fast we can turn in a step. Step is a fraction of a second between frames. So let's say we can turn, let's just say 1 radian per second right now. And so times step, and then yaw plus equals steering times turn rate. So if the yaw, if the steering is 1, for example, we'll turn at 1 radian per second, which is, it would take us like 6 seconds to go all the way around. Or no, radian. Yeah. Yes. Something to that effect, right? And then speed. We will just set, oh, this is state.yaw anyway. It's gonna have a problem. Did I grab the state? Yes. Oh, somebody made food and I am so hungry. We'll just set speed equal to acceleration for now, just like we are. Okay. Alright, and then we will take the current yaw we will set so far yaw is less than 0.0, state.yaw plus equals math.pi times 2. So we'll wrap around, else if state is if state.yaw is greater than math.pi times 2, then just to keep it bound within plus or minus 2 pi. Actually, plus or minus pi should have worked. Anyway. So state yaw, that's good. Then from that we can pick velocity. We want that to be whatever this is multiplied by new vec3d, which would normally be like 1 meter per second would be that. So we're going to set this to steer to speed. I got compile problems. No such property speed. I am speed state. Okay, and then so it occurs to me my if true is not big enough. So we want to set linear velocity to be the velocity. And we already set the orientation. I think that's all we need. I mean, it's guaranteed not to work the first time, right? Clean path. Go to here. Step. Okay. It's a straightforward path. Can we make it? Yeah, see, it's trying to loosely walk. Oh, no. She's going in a circle. Oh, yeah, see, there now she's trying to turn around. I think our turn rate is set way too low. Can she make it there? And then she's going to try to turn back around to go the other. Yes. It's working. It's just her turn rate is so slow. Yeah, she's gonna keep circling around that. She can't make it. Because her turn radius is so slow. Yeah, okay. Stop walk. Okay, so turn rate, let's say she could turn 1001. Let's say she could turn all the way around in a second, right? And oops. Let's set this like it's a constant. So turn rate, steering times turn rate times step, okay? So now she can turn a little faster. I think we can't walk because the path has been cleared yet. Clean the path, go to here, step, step, okay, now, walk. Okay, she's gonna try to get to the, she can't quite make it there. There she goes, she did. And so she slows down when she gets to the waypoint, which is a problem. Hey, but she made it. Okay, so steering is kind of working. She shouldn't slow down as she gets to the waypoints. And so what we should do... Yeah, so if the waypoint is behind us, we'll set acceleration to 0 so she can turn to face the waypoint. And otherwise, acceleration will be 1.0, whatever the maximum meters. Oh, so that's basically 1 meter per second. And then if we get there, acceleration 0. Right. So I think this is still going to have her stop at every waypoint. Clean path, go to here, step, walk. Well, that was really fast. Why was that so much faster than when we did this down here? Because we just set the linear velocity to be the direction, which was going to be of length 1. Speed equals the acceleration. Acceleration is always going to be 1 or 0. Then why? Just log the speed. Clean the path, go to here, step, walk. Oh. Yeah, so she needs to be able to slow down. Or we can set the arrival stop walk. So now I think if I walk again, will it work? Yeah, she can't. She's walking so fast though. I don't know why. Speed is 11111. It would have been 1 here too. Oh. No, because I never normalized. So let's set max speed to be 0.5. And so down here, we'll set max speed to that. And if the turn is really wild, we will slow down. Like if we're at the max turn radius, we'll slow down for a second. So let's clean the path, go to here, step, walk. She's never gonna make it. We need to, so stop. Oh, she figured it out. Okay. Stop walk. I think this needs to be slower. Slow way down when you can't turn fast enough. Clean path, go to here, go to here, step, walk. Check it out. Alright. So she steers through the path. And let's make sure she can still go upstairs. Go to here. Step, 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 step. Okay. Let's make sure she can still go upstairs. Walk. Oops. Hey. Yeah, we probably need to shorten that radius a little bit. She can't go up because she can only steer by yaw at the moment. We don't have any up-down steering. Let's make her go back over to here. Or here. I just want to set her up for the next run. So walk over here, baby. Oh, stop. I didn't make the path. Step. There we go. Walk. Yeah, see, she needs to decide she's close enough to that one. Yeah, I need to change the arrival distance. To maybe 0.2. I'll make it less than or equal to also. So this will make it a little better. I don't think I can do this again. I don't think I can just, yeah. Clean path. So yeah, she's got no up down. Let's just set an up. And so so we'll just set up equals vrel dot y for now. And then in here, velocity dot y equals up. So that should let her just walk up in whatever direction she's walking. It's not correct, but it could be correct enough. Let's try going up here. Oops. Got to figure out why that happens. Yeah, see, the physics engine, there we go. All right, step, 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 step. She's figured out her way up. Now let's see if she can walk there. Follow the path. She's following the path. Can she follow the path up? Yes, she's almost doing it. Come on. Yeah, because there's no probe, right? She's not going to steer around it. What's my... Oh, I have it right here, right? Body debug. Yeah, she's caught her foot is caught on there. Yeah, see? It's her foot caught right there. Because we're not using physics forces, we're setting the velocities directly rather than setting the physics forces. She can't solve the problem. Let's try having her start over again. Sometimes the randomness of how she approaches could affect things. Yeah. See, it crawls up. It's trying to crawl up. Why isn't it... I think she arrived at this waypoint, and she's trying to get to this waypoint. Otherwise, she would keep trying to go up. But she got close enough to this one that it considered her there. That's going to be a problem. Well, anyway, that's a problem that the steering thing is supposed to fix when I get the probe implemented. But I'm not going to have time to do the probe tonight. Is there anything else you guys would like me to... let me see if we can make her do this. Yeah, no, see, it's going to start over again if I walk. Blink. Oh, that's interesting. She didn't finish. There we go. So I got like 10 minutes left. I don't think I'm going to be able to implement probes. I could save that for next time. Maybe I'll work a little bit on getting us closer there, and we can talk about the probes next time. I am going to try to cut a release this weekend, so look out for that on Sunday probably. But I think we're getting pretty close, right? We've got her following the paths. She gets stuck. That's the thing we're trying to work our way around. So I'm going to stop her walking, clean the path, and make her go somewhere else so that we have something cool to watch. Step, 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 step. There we go. Walk. Let's see success in the end, right? So up and down is always going to be the trickiest part of all of this. I wonder if she could walk these passages as well. So when she gets here, let's clean the path, have her go to here. Oops. Okay, step, 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 step. Okay, you go walk there. So yeah, I have a feeling I'm going to play with this for a bit tomorrow. But I'll save the bulk. I guess I'll save the bulk of it for next live stream. I think maybe this is a good... I don't know about you guys, but I feel like there's educational content in here. I know I'm learning things. Okay, so step, 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 boink. Let's see if she can walk through the narrow passage. Nope. Same deal, right? She can't. Yeah, her shoulders are too wide to allow her to go. And she can't steer left or right to get... That's really unfortunate. Well, first of all, I need to fix these. Yeah, so it's... I bet it's her foot that's caught on there. No, it's not, in fact. Where is the contact? She's got no contacts. Like, not even a floor contact. That doesn't make any sense. So it could be that my contact debug is broken. Because she should have some contacts. There they go. I had to turn it off and on. Yeah, so I think they disappear over time. Or she goes to sleep? Anyway, we saw for a second she had like a foot contact there. And then it's gone away. So I need to debug that as well. So that's the goal, right? She should be able to walk up and down stairs. She should be able to make it through the same passages that the player can. But frankly, if this is the only thing that ends up not working, I'll be happy, right? If she can make it up and down stairs, I can do a lot with that, because most passages are not going to be that narrow. But I think this is where I'm going to end it. Thanks for watching, guys. If you have any other questions that were not covered on the live stream, please leave a comment on the video and I will answer them. I don't get that many comments, so I respond to all of them, or I'll at least like them and stuff. So if you think of topics for future videos, that can also be a good comment, or just any questions, comments. It's great. Like the video, subscribe if you're not a subscriber. I do like seeing new subscribers. And yeah, definitely like the video. Just, it's easy. Click down the little thumbs up guy. And the more comments you make, the more YouTube says, hey, I think I should show this to other people. So thanks for watching, guys, and I will see you next time.